So this is problem sheet 3, and I give you the model answers for this. There are other answers as well, but I just run through the questions for you and the solutions as well. Let's look at the first question. And you've been given a difference equation, and you've been asked to draw a block schematic diagram, direct form 1, direct form 2. Direct form 2 means feedback first and feed forward second. Direct form 1 means feed forward first, feedback second on the right hand side. So we take the first one, we write this equation, xn multiplied by 7, that's that part, plus wn minus 1, this is wn, by 1 delay you will have here wn minus 1, multiplied by 0.25 will give you this bit, you add them together, you get your first equation done. So the first equation is done now. Look at the second equation, yn is equal to 2 times of wn. wn is here, feed by 2 multiplier, and minus 4 times of wn minus 1. From here, delay, that gives you wn minus 1 at that point, wn minus 1, multiply by minus 4, add them, you get this equation. That's your first part. So that's, we call it the direct form 2. If you want to look at direct form 1, we know, we have learned in the class, if you have a system 1, S1, and if you got system 2, and input is xn, output is yn, we can switch the system around, and here system 2, and here system 1, we learned in this class, in the class we learned this one. You can switch them around. System 2 come here, system 1 come here. So what we do the same thing. What we do here is we move this system in here, move that system in here, and draw the diagram. And you will find still you have the 7 there, the multiplier. The interesting thing would be, think about it and see, this 7 could we have, instead of here, could we have 7 here? And then you get yn. What would happen? Write the equation again and have a look whether that's possible. Well, if you look at the system here, if I put a 7 here, or if I put a 7 here, it does not matter, right? Write the equation and show that is allowed, and that will give the same equation. Have a look. Okay. So that's the first question, very easy question. And let's look at the second one. In the second one, you've been given a system 1 is related by Pn and Xn. System 2 is related by Wn and Pn. And you're given that equation 1 and 2. And the equation relating Yn and Xn also given here. However, in system 2, we've got 2 constants, A and B, 2 multiplier. We've got to find A and B by knowing this equation and by manipulating these two, combining those two. So what we do first is, we write those equations first. First write that equation, that comes here. Then write this equation, comes here. Remember, this equation can be modified as xn is equal to Pn minus half Pn minus 1, which is important because we need xn here, remember? So what I'm going to do first is, I start with this equation and say I need yn minus 1. So I replace n by n minus 1. I'll get yn minus 1, and also I get yn minus 2, which I have as well here, yn minus 2, yn minus 1. It's good to have that equation. Then I need a half Pn minus 1. And I have, so what I do is, in order to get a half here, I multiply everything by half. I get half yn minus 1, and half of that, half of that. So that's equation 3. I now take away equation 3 from equation 1. That means I'll have yn minus half yn minus 1, that's that part, equal to that minus that, that minus that. So you do that one. And here, if you take beta out, you get Pn minus 1 over 2 Pn minus 1, which is Xn. So this is written as Xn. Therefore, your equation will end up as number 4. That's your equation. Now you see, this equation is Yn there, Yn minus here, Yn minus 2 there, and Xn there. That's similar to that. So they're exactly the same. Therefore, now I could say from 4 and 5, I can say now they're identical. Therefore, here alpha plus 2 is equal to the coefficient 3 over 4. Okay? So alpha plus 2 is 3 over 4. And beta, and if you look at here, is 1. So beta is 1, alpha plus 2, and simplify alpha here, 1 over 4. So in this equation, is in difference equation that you need to manipulate to get it this form, that output versus input, and then equate the coefficients. Try this question again yourself and see whether you are able to work through this. Let's come to the next question, question number 3. This is Xn, diagram given, Pn, and there's a delay, so this will become Pn minus 1. That's all you need to know. So basically, they want to write the equation relating Xn and Yn. That's all they need to be done. So first one, we write what is Pn, Xn comes in here, Pn minus 1 multiplied by A is that. What is Yn? Yn, Pn minus 1 multiplied by C plus Pn multiplied by B will come in here. That's number 2 equation. And from 1, I can find Pn minus A, Pn minus is Xn. That's what I got that. And remember, we normally do n by n minus 1. So you go into it, replace by n minus 1. You'll get Yn minus 1 is equal to Bpn minus 1, Cpn minus 2. And you now multiply by A to make Ayn minus 1, because remember here we have got Apn minus 1. That's what we want. That's why you multiply by A here. You get Apn minus 1. Immediately come in Apn minus 2. That's equation 4. The same as previous question. And 2 and 4 you combine them. As soon as you combine 2 and 4, what you're doing is you're subtracting that minus that. So that's what you're doing. You get B times of Pn Apn minus 1, which we already know from here. Pn minus Apn minus 1 is Xn. So we got that, that will be Xn. C, and this is Pn minus 1 plus Pn minus 2. If you substitute here n equal to n minus 1, you get Pn minus 1 here. Bring this one minus Apn minus 2 will become Xn minus 1. So you got Xn minus 1 for that. So that's the equation really. And then you really need to write as Yn is equal to Bxn plus C Xn minus 1. You don't need that. Plus A Yn minus 1. That's the way you finish. You find the current value of Y depends on the current input, the input, and the past input, one sample delayed, and past output, one sample delayed. So in both questions, if you look at it, they're similar. We are trying to eliminate the intermediate variable Pn. In the previous question, we were trying to eliminate the intermediate variable Wn. That's the philosophy in these two questions. As soon as you remove them, you get your relationship between Xn and Yn. Think about this, redo this question again and have a look. Very, very straightforward once you understood. In the second part of this question, they ask you to write the difference equation. Now you can see in this difference equation, very simple equation, the output is not fed back at all. When the output is not fed back, it's only feed forward system. Feed-forward system is very straightforward to write. Okay? So here we go. Let's go with this. Xn delayed by t, xn minus 1 here, xn minus 1, and then this is xn minus 2. Add them together, you get qn. So qn is xn minus 1 plus xn minus 2. Then we get pn. Pn is xn directly, and then you have got xn minus 2 and xn minus 2 delayed by 1, so xn minus 3 here, and you add these two together, you get pn. And then yn is equal to pn comes in, and here this is qn multiplied by beta, so qn multiplied by beta. So if you add, these are the three equations, all you need to do is now substitute for pn here and substitute for qn here, you get one equation. And then when you expand it, the current output equal to alpha times of current input, beta times of previous input, one sample delayed, beta times of previous input, two samples delayed, alpha times of previous input, three sample delayed. So there is no feedback, therefore it's a feed-forward system. Question 4, next question, same principle. You have to write the system's equation for this. And that's what's given. Always keep it as yn and bring this to the other side. So yn equal to half xn, 3 over 2 xn minus 5, yn minus 1, yn minus 3. So they haven't told you direct form 1 or direct form 2. So you can pick and choose what you like. So it's the easiest one is xn multiplied by half, goes in here directly, then 3 over 2 xn, so 3 over 2 xn minus 5. So you got xn delayed by one sample, two sample, and there are 5 of them, xn minus 5, multiply them, you get the output there, keep that there. Then you come back, yn delayed by one sample is yn minus 1, multiply by minus half is that. Then delay by 3 samples, 1, 2, this is yn minus 3, multiply by minus 2 is that, add them up, with this bit, you get the signal yn. So these are some of the questions that you probably did in the class, and you just redo them to make sure. If you do it only, you'll get the analytical skills. It's important for you to do this once or twice to make sure that you have the analytical skills. Because when you go into transform methods in chapter 3, these analytical skills are important. Okay, let's move on to the next question. This is very simple. Yn equal xn minus xn minus n, xn minus capital N. So we have n delay here. 1, 2, 3, 4, nth delay. So this is xn minus 1. You minus 1 means you have a multiplier minus 1. Input subtracted. So this is actually input is subtracted. You get an output. That is a feed-forward system. Very important system actually. Have a look at this system. Yn, axn minus 1. A to xn minus 2. Yn minus 1. B1 and B2 yn minus 2. So we draw the feed forward first, because you have not been told canonic form or any form. So you just do this first, A0, xn minus 1 there, A1, xn minus 2 that, and then yn minus 1 multiplied by minus B1 to give that, yn minus 2 here, multiply by minus 2 give you this, add them up. If you have said that, draw this in a canonic form, then you're going to think, you're going to have minimum delays. Here you got 1, 2, 3, 4. So it's not a good idea to have that. So canonic form would be then look like, so in a canonic form, you got xn coming in, and you got a plus here, and then you got one delay, t, and second delay, t, and then you have here is minus B2, that goes in here, and that's become minus B1, that goes in there. The output then goes to A0 directly, plus that's your output yn, and then you got xn minus 1, So that one is xn minus 1, which is a1, and then xn minus 2 is a2. This system is same as that system, no difference at all. Exactly same, and we did that. You can switch this around, you see, and then you get that system. That's canonic system. The delay, instead of 4 delays, you got 2 delays. So you can redraw the system as soon as, so once you have learned enough, you would decide by looking at the diagram, you should write the difference equation immediately. Given the difference equation, you should write canonic form most of the time. You should do canonic form because it's so simpler, right? You don't have too many errors. So add a 1, add a 2, and you can combine these errors if you want, but you know, okay? Here's another question. I think this comes probably later on in your chapters. If you have a system equation given, this is a feed-forward system. There's no feedback. So the current output is input, delayed input, and add them all up. So you've been asked to find the impulse response. Impulse response will be, if you actually analyze the impulse response, like start n equal to 0 and substitute, you will find y0 is equal to 0.1 x0, yes, and this one will be x minus 2, x minus 3, x minus 4, x minus 6. So they're not going to be there. Impulse we are talking about. Impulse at that point, at the n equal to 0, is delta 0 equal to 1, because we are talking about impulse response. So the input is an impulse. Xn is equal to delta n, which is x0 is equal to delta 0, which is equal to 1. In all the other places 0. So you can see at n equals 0, you get the first value, which is 0.1. Xn minus 2, x minus 2, minus 3 are previous values. The system is not when you say system is a initially relaxed system, then this will be all 0. X minus 2 will be 0, x minus 3 will be 0, x minus 4 will be 0, and so on. Initially relaxed system. So you got first y naught is 0.1. So let's go n equal to 1, y1. What will happen to y1? You will have put in the equation 0.1 x1 plus minus 0.1 x0 there. When you substitute, x0, and then when you go further, this is not x0, it's x minus 1, this is x minus 1. And when you go next one, x 0.8, x minus 2. So this will all contribute to 0, 0, 0, x, this is x equal to 1, x1 is 0, so whole thing is 0. So you can see x naught, first value is 0.1, impulse response, second value is 0. Now we put n equal to 2, what will happen? Y2 is equal to 0.1 x2. x2 is 0. Minus 0.1 x1 here, that's equal to 1. And then rest all 0, it will work out to be. So minus 0.1 is the output for n equal to 2. So see minus 0.1. And if you work your way through, the impulse response are going to be very simple form. That's what the question is, going to be the coefficients will come out as the first value, second value. Second value is xn minus 1, which is not available, so that will be 0. Then this is the third value, that's the fourth value is that, fifth impulse response value that, sixth one is right. After that there's nothing, then it will be 0. So that's what we have written. First value is 0.1, second 0, that's the next one, that's the next one. These are the coefficient of the filter, and then 5 is missing, so that will be 0 as well, so that's 0, and then sixth, 0.1, after that is all 0. So for a feed-forward system, if you are asked what is the impulse response of the feed-forward system, just the coefficients, and then it's all zeros. Okay? We will learn that in the next chapter as well. Okay, now we come to convolution. Now in this case, you've been given two sequences, 1, 2, and you've been asked to do a convolution and to show the output is this. So we'll write the convolution equation. First one is input is given. Pn is equal to a and un. What does that mean, a and un mean? A to the n, assuming a is less than 1, will be like that. Sorry, like that. And by having un, you are making the signal only quotient when t is greater than 0, greater than or equal to 0. So you make the signal only that part. So negative part is not there. Similarly here is the same thing. You multiply to make the signal quotient. So now we are going to say convolution. Convolution is Pn convolved with Qn. The equation of the convolution is what? Is summation. You've done that. Yn convolution equation. This is here Pn convolved with Qn. The convolution equation will be sigma P K Q n minus K. Right? It's going from 0 to something, but otherwise you put a un there. So you will find sigma k equal to minus infinity to plus infinity. A k u k. That's that one. It's all in terms of k now. Yes? And then you have got b, n is n minus k, see? N minus k. So bn minus k, un minus k. Agreed? So you will find this one is equal to 1 when k is greater than 0 because u is a function like that. And this is 1 when, that's k, n minus k is positive. If this is positive, this is 1. That means k is less than n. See, n is greater than k, so k is less than n, less than equal in that case. Yeah. There are the two functions available. Therefore, you can say from here, from this one, the limit will change to 0. This will go to 0 because it starts with 0. So this first one is 0. And here, k keeps going to infinity, you see. But k should be less than or equal to n according to that. So therefore, this will be k is less than or equal to n. Got the idea? Now, because you have changed the limit, you only have ak, bn minus k. That's all you have. So if you now simplify this, you can say ak bn times b minus k, and you could then say bn is a constant because this only depends on k. So you take the bn out. Yeah. And all you have is ak times b minus k, which you can write as a over b to the k. So that's the next equation. Now if you expand this one, it's a power series. K equals 0, put it in 1, a over b squared, a over b to the n. The summation of a power series, you have done that. 1 plus r squared plus and so on, rn minus 1 is equal to 1 minus r to the n over 1 minus r. If this is n minus 1, you have got to add one more to make it. Huh? So here is n here. So the answer must have n plus 1 here. Look, n plus 1. 1 minus r is a over b is the common ratio. 1 minus a over b to the power n plus 1 over 1 minus r, which is 1 minus b over a. So that's your answer. Now you need to simplify this. When you simplify this, what will happen? This will be equal to, you will say this is equal to b to the n, it's already there, times, common denominator is b n plus 1 minus a n plus 1 divided by b n plus 1. That's on the top. On the bottom, it will be b minus a divided by b. Now what happens is this b flips around to the top, become bn plus 1. That's that one. And this bn plus 1 comes on the bottom. That's there. So on the top you have bn plus 1, an plus 1 here, over b minus a there. These two cancel out. That's what you have. So a minus b you can write as minus b minus a. You can write. Yeah. So you switch this around. Similarly, you switch this both of you around, you get that answer. You can leave the answer that way, but you were asked to show it that way, so you need to switch them around. So that's how you do the convolution. You just have to be careful here when you are multiplying. This part and this part, you need to just learn by looking at the diagram. When they give the un function, you say, all right, un is 1 when n is greater than 0. un minus k greater than equal to 0. Minus k is 1 when n minus k is greater than equal to 0. So n is greater than equal to k. Therefore, k is less than equal to n. That's how you get the maximum value here, n. Okay, there are a lot of scribbles there, but if you follow it, you'll understand. At the end, when you look at it, look at a massive number of scribble there. But you just go back and go through steps, right? All right. Question number 7, have a look here. You've been asked to consider system discover a difference equation. You've been asked to find b in terms of a so that the summation of the impulse response is equal to 1. That's given. So let's write this equation. That's your equation. We are trying to find the impulse response, xn equal delta n. We now do iteration one at a time. N equals 0, y0, n equals 0. This will be y0 here, y minus 1, x0. That's 0. Initially relaxed system 0. x0 is 1, so it's b is the answer. And you go n equal to 1. N equal to 1 is y1. y1, 1 is y naught. So a times of y naught, which you already found out as a b. Then b times of x1, which is 0. So you will have a here. The answer will be, and a times of a times of y1. So the second one, this one is then a times of b is that one. If you iterate same way for the next one is b a squared b. If you put n equal n minus 1, when you have 2, if you look at you have got a 2 here. So if you have got n minus 1 and you will have an n minus 1 here times b. So for hn you will say, instead of, if you put n here, that will be n as well. So a to the n, b, n is greater than equal to 0. That's your impulse response. Instead of having n is greater than equal to 0, instead of writing that condition, you could just remove that condition and put a un that will ultimately take care of that condition. Because un is a function, as I said to you like that, so it will automatically take care. So you can write that way or you can write that way. Now we want to look at this. The summation of the impulse response here is 1. So we want to sum the impulse response, 0 to infinity. Sum means summing this one, a and b. So if you now substitute b is a constant, take out b and just put a equal to n equals 0, 1, 2, 3, you get a power series or geometric series. And it's going up to infinity. So if you have got 1 plus r squared plus plus r to the n minus 1, and if you find s to infinity, this will be 1 over 1 minus r. You have learned that. So our b is still there. The common ratio is a, so 1 over 1 minus a. That's given 1 equal to 1. So that's it, make it equal to 1. Therefore, from here, b equal to 1 minus a. That's your relationship between b. All right? Have a look through the question again. And you need to understand this iteration part. Sometimes you do, sometimes you don't need to do. You just have to work out. When you learn transform, you may be able to avoid this. You do through the transform and take the inverse transform. Okay? Question number 8 is a lot of text in it. That is the linear system, time invariant, and causal system, and linear, nonlinear, causal, time invariant system is already explained in there. And it's in the lecture notes. I didn't want to repeat that answer here. So what I've done is, for question 8, you will get a printed solution rather than explained solution, because it's just so easy to follow and there's no need for me to run through that. So go and look at the printed solution, which will be loaded up. It will be uploaded onto the web and you can have a look, or in the Moodle. Now the last question is convolution. 2 sequences have been given and you have to convolve. Right, how do you do this convolution? There are many ways of doing it. You've probably done in the class 2 ways. One is the graphical convolution. Second one is just table method. Let me just explain the graphical method here and have an idea, and then you can repeat this using the table method, which is outlined in the notes. Okay, here's your sequence, 1 and 2. The first question you'll be asked is, what are these sequences? That means this is my xn coming in here. This is my hn or hk. And I'm asked to find yn. That's all it is. Find the convolution over two sequences means you basically xn convolve with that will give you yn. So xn is here, hn is here. How do you find it? That's what the question is. So what you do, you write the equation, and then this is written as xk hn minus k. Okay? First step is you see, I want to find the first value, y0. What is y0? Is summation of k equal to minus infinity to plus infinity xk h minus k. That's all it is. So I take hk and xk and h minus k, multiply them and sum them. So let me start with xk is here, hk is that one, but I need h minus k. So you flip them around that position for this one, and this will be staying there. That will come here, that will come here, that's h minus k. Now what you need to do, you multiply these two, and you're trying to find y naught. That's what you're trying to find. When you multiply, that and that multiply will give, that's one value. 1 and 1 is 1. That time there's nothing, 0. That time that nothing, 0. That time that there's 0. This and here is 0. This and here is 0. So you end up with 1 multiply 1. All the others are gone. It's 1 when you add them. So when you multiply these two sequences, that and that, you will end up with 1. So your convolved output y0 equal to 1. That's all the first answer is. Now you can do y1 and do the same thing. y1 that much xk h1 minus k, and shift this one 1 minus k, mean you shift this way 1 and then multiply and add. So let's do the next one. Yeah? We can't do for all values, every value, but just to give you an idea. Next one. Next one is n equal to 3 we want. So you go y3 is equal to sigma, we are going to add in let me take it out, x k h 3 minus k. I know h minus k is that. 3 minus k mean I shift them 1, 2, 3. So I comes at that position. That's my 3 minus k. And xk multiplied by 3 minus k. I multiply this to 1 and see what the output is and sum them. This says multiply everything and sum. That one multiply by that 0. That one multiply by that. You have to multiply the corresponding one, right? 4 times of 1 is 4. That multiply by that is 0. That multiply by that is the same positions, is 2. So 4 plus 2 should be 6. So at position 3, you will have 6. Similarly, if you do for all of them, this is your fine convoluted output eventually. That's what you will get. So you will find that if you start with 1, 2, 3, 4, 5, 6, 7 values, when you do the convolution, you will end up with 7 minus 1 value, which is 6 values. 1, 2, 3, 4, 5, 6 value. Convolution always give you one less. You can try any convolutions. Okay. So let's move on to the next question. It's a similar question, no difference at all. Just to give you again another experience. So this sequence this time is that, and Hn is this one. Now we want to evaluate this equation. So let n equal 0. So first n equal 0 means h minus k. You got that? Oh, we did n equal 1 here. Oh, brilliant. So we go yn, y1 is equal to sigma x k h1 minus k I need. And k goes from minus infinity to plus infinity. Yeah? 1 minus k. hk is here. 1 minus k means shift this by 1 sample. So, oh, sorry, that's hk. H minus k there. And 1 minus k, when you shift this by one sample, so you shifted that to one position, so you get that. Now you multiply these two. That one multiplied by that one is 1. That one multiplied by that one is 2. Is it 2? 1.5, I think. Sorry, this is 0.5. 0.5, is that right? H1, yes, this is the height's different. This is 2, this is 0.5, 0.52 is 1, you'll have. Second one is, this is 3 multiplied by 0.5 again. So that's 1.5 plus 1 is 2.5. Do you understand? So you multiply this one with that, you get value. This one with that, you get value. This one, there's nothing. This one, there's nothing. So only those two, add them up, you get 2.5. So that's y1 is 2.5. And similarly, I've done another example. For n equal to 4, you can try them. H minus k, 4 means you're going to shift 4 times. That 1, 2, 3, 4. That will come to the 4th position here, at the 4th position there. And that's 4 minus k. Now you multiply these two fellows and add them. You get 0.5 at that point. So you can say that at y4 is equal to 0.5. Eventually, when you execute for all of them, you will get, that's your final output. Now if you go back again, and you started with 1, 2, 3, 4, 5, 6. So the output should be 6 minus 1, 5 value should be there. Let's see whether we have 5. 1, 2, 3, 4, 5 values. So that's all really the convolution. It's very easy just to get the principle behind it. So convolution is something, you have your sequence here, you got another one, you flip them and shift them and then add them. Multiply and add. Okay? That's all you have for that particular tutorial number 3, and keep trying them out yourself. I just want you to get this analytical skills. A lot of students don't get the skills, immediately, by the mid-exam. They don't have it. They do have it afterwards, but I want you to, that's the idea behind recording these tutorials, so you have an idea and you can work your way through and see whether you get the answers. Okay, thank you.